Now, we will discuss transformer on load condition. That is, when the load is connected to the secondary terminal, load terminal voltage is V2 and supply voltage is V1. So what is there? This R1 is the resistance of the primary winding and X1 is the reactance of the primary winding and R2 is the resistance of the secondary winding and X2 is the reactance of the secondary winding. Now, whether transformer is connected to load or not, the no load current is always there. That is when the secondary is open, the minimum current flows in the primary. That is 5%, maximum 5% of the full load current is flowing in the transformer primary winding. That is responsible for the heat and magnetization of the core. Now, we will draw now the load. This one is the load. So, load is load may be resistive load may be inductive load may be capacitive load. So, if the load is resistive, that means we know that when the voltage across the resistance is mm, in line with the current, so the load can be resistive. If the load is resistive, that then voltage and current that will be in the same phase. If the load is inductive, that means the voltage at the load terminal will lead the current. And load, if the load is capacitive, that secondary current I2 leads V2. So how to draw the phasor diagram? So remember, whenever we draw the phasor diagram, that times always no load component will be there. So the drop is I1 R1. As this current is I1, in the primary side drop is I1 R1, I1 X1. In the secondary side, the drop is I2 R2, I2 R2, and I2 X2. So how to draw this phasor diagram? First, we will draw this way. That is, this is O, and in this direction, the flux phi is there, and just opposite to the E1, E2 is 90-degree lagging. Then we will draw the no load current I0. No load current I0. Then we will draw the horizontal component and vertical component. This is IW. This is IV. Next, you have to consider whether is load is resistive load or inductive load or capacitive. If the load is resistive load, that time we'll draw V2 and I2. If this one is V2, the I2 will be in the same phase. Okay, V2, I2 will be in the same phase. But if I draw a load for say inductive load. Generally, all loads are inductive. So that time what to do? We will draw in inductive load V2 leads I2. So first we draw. So this is V2. This is V2. This is V2. Then we will draw I2 current. Here V2 leads I2. This is inductive load. So now you draw the reflected values of the secondary current to the primary side. So just project this I2 current in the primary side. This is the primary side, this is the secondary side. This is I2 dash. I1 is the phasor sum of I2 dash and I0. So you draw the parallel. Let's try to use scale. This is phasor sum of I2 dash and I0 is your primary current I1. Now I'm rubbing this portion. Then the primary current. Now you take this E1, the opposite of E1 is equal to E1 dash. So E1 dash over here. As we know, V1 by V2 is equal to E1 by E2 is equal to N1 by N2 is equal to I2 by I1. This is its transformation ratio. So this E1 dash is nothing but the same magnitude of E1 but in reverse. Then you draw the drop for the primary winding. What is it? I1 R1. So I1 R1 will be in phase with I1. So parallel to this I1, you have to draw I1 R1. You draw I1 R1. Next, inductive draw. Inductive draw will leave 90 degree. So here it will be 90 degree. This is 90 degree. Inductive drop is 90 degree. Now you connect this O with this. What's this? This is your V1. So V1 is a phasor sum of E1 plus I1 R1 plus I1 X1. And this one is the equivalent impedance in the primary side, ZE1. Yeah, in the secondary side, we have to draw the secondary draw. So that time, after V2, that is, we have to draw I2 R2. This will be in phase with I2. So parallel to this I2, you draw I2 R2. I2 R2. Then you draw I2 X2. I2, X2. Then you connect. So this is your E2. In the secondary side, what we can see, E2 is greater than V2. In the primary side, we can see V1 is greater than E1. So in practical transfer, that's process. So this is the result. So E2 is a phasor sum of V2 plus I2 R2 plus I2 X2. V2 is the phasor sum of E2 is the phasor sum of V2 plus I2 R2 plus I2 X2. Whereas in the primary side, what we can see, V1 is equal to E1 plus I1 R1 plus I1 X1. Clear? So if this way you try to draw the phasor diagram on transformer on load condition. When the load is inductive, that time the diagram will be like this. If the load is capacitive, that time I2 will be phasor diagram is very important and we need practice. Thank you.